Now that you've learned how geospatial data works, it's time to move on to the thing that probably brought you here in the first place, making maps in R. We'll start out by making static maps. The great thing about making static maps in ggplot is that, assuming you already know how to make charts in ggplot, it's not that much more complicated to make maps. Let me show you how it works. Okay, I am in RStudio. You can see, first of all, this line here, options, tigris, use cache equals true. I basically always use that because geospatial data, as you may have realized at this point, can be really big. So if you set that option there, that will make it so that if you run kind of the same query over and over, it will use a cache of that data, not having to go grab it every time, which takes a while. Next, I'll load tidyverse, tidycensus, janitor, and SF. I'm going to bring in some data, and I'm going to show you kind of like a real example of bringing in some geospatial data, which we'll then use for plotting. So the first thing, I know I want to access data on English language speakers and speakers of other languages in the US. Now, of course, I did a little prep for this, and I know that it's in the data set is what's known as subject tables. So it's in the ACS5 in 2023. I Googled and figured out that the table was S1601. So here I'm bringing in that data, and then I'm doing a filter to figure out kind of what those variables are. And you can see that I've got them here. Now, there are a couple things that I want to do. Okay, I ran this again just so it's a little bit bigger. So you can see, basically, I want to calculate the number of folks who speak languages other than English in various counties. And so I figured out that this S16, you can read it there, is the variable that I'm interested in. Actually, let me do a view so it pops up here. So just to show you, I basically kind of look through it here and figure out, okay, this is the total population, 5 years and older who speak a language other than English. But because I want to calculate the percent, I also need to know, like, what's the total population greater than 5? So for that, I look through, and again, I could figure out that there is a variable that's the total population. So within the getACS function, there is an argument called summary var. What that does, in fact, I'll run it, that then creates an estimate, which is the value. So in other words, the estimated number of people in each county who speak languages other than English. And then the summary estimate is like the total population, the estimated total population. So I'm going to save this. I want to, do that get ACS, but I'm also adding here geometry equals true. So just to show you, if I go down here, in fact, let me comment that out just so we can kind of run it line by line. So I'm bringing in that data. You can see now, because I did geometry equals true, it's geospatial data, which is awesome. So I'm just running clean names from janitor. I just get kind of bothered by the uppercase of GeoID and name. That will clean it up. So now it will be just GeoID and name lowercase. So to calculate the percent, all I need to do is do estimate divided by summary estimate. And then I'm just going to select name and percent. So in other words, the name of the county and the percent. Perfect. So now I'll go ahead and save that. So I've got my speak language other than English. Now check this out. If I want to make a plot, all I have to do is put it in ggplot and use geom_sf. So here I'm piping it in, and it takes a second because geospatial data is slow generally, especially when we have like all of these counties. There are 3,000 something counties. So it just takes a little while. Okay, so we've got our plot there. Now, Alaska's giant, which is true. Alaska is giant, but it just doesn't look great, right? Having Alaska up here. We've got Hawaii here, Puerto Rico down here. Fortunately for you, there is a function called shift geometry from the tigris package. So I'm running a library tigris, and then I do shift geometry and watch what happens. Now it moves Alaska, Hawaii, and Puerto Rico to places that are easier to see. And this is useful not because it's geographically accurate. Of course, Alaska is not down there off the coast of California and Arizona. Not that Arizona has much of a coast, but again, just way easier to see. Okay, our map has all of the counties, but they're all just gray because we haven't mapped any data to aesthetic properties, which of course is at the core of the grammar of graphics, which makes up ggplot. And I assume if you are watching this course, you are familiar with the basics of ggplot. So if I go down here, you can see on line 49 how I've added my aesthetic properties. I'm saying here I want fill to be equal to %. So when I run that, watch what happens. There we go. We now have a map that shows the % of folks who speak languages other than English in the kind of lighter blue. For counties with lower percentages, those are the kind of darker blue. Now, I know this isn't a great map. I know it's actually really hard to see. If you look down on the kind of like Texas border, basically the border counties, which of course makes sense, you're going to see a lot of folks who speak languages other than English. So I know this isn't a great map, but in the next lesson, we'll talk about how to improve it and make it look much better. For your turn, I want you to import a data set that I've created on the number of refugees from each country in the world. This data set is in GeoJSON format, so you can import it with readsf. Then I want you to use ggplot to make a map of this data with countries sending higher numbers of refugees in a different color than countries with lower numbers.